Bonnie, spare me the technical analysis. I need a direction, right or left.
Action! You and me.
Slow down, slow down. All right, we're getting close. Kit signal's dead ahead. What's the problem?
There's interference. Someone's trying to reprogram from the semi's console simultaneously.
So I scored myself these two HP Portable 110 and Portable Plus computers from 1984, including a matching 3.5-inch floppy disk drive. As you may or may not know, I'm a huge fan of Knight Rider, and so it's no surprise to learn that these machines were featured throughout the late series run, even though we only get to see brief glimpses.
This is the one time I'm glad you're not with me, Michael.
But not everything we typically see in films is actually reality. So the question is, what is it all about, these 38-year-old machines? Obsolete computer technology is my passion. I'm the vintage collector, and these are my stories. Originally, I had intended to have the video on these machines kick off this channel, sort of like a backdoor pilot to my Knight Rider related sister channel. Well, things sometimes really don't go as planned, but finally, these precious machines get a treatment, not without yielding some obstacles to get around, of course. The HP 110 series consisted of two similar type models, the classic HP Portable 110 and the later years 110 Portable Plus model. The former called for $2,995 in 1984 and the latter for $2,295 in 1985, and the main difference being just a faster modem and the larger 80 by 25 characters display on the Portable Plus. Here we have both of them side by side, including the 9114 floppy drive and an original owner's manual for the HP Portable 110. Released to the market in 1984, the HP Portable 110 sported an ATC86 CPU clocked at 5.33 MHz and a whopping 272 KB of RAM. It was even featured in an episode of the 80s computer show, The Computer Chronicles.
Where to, mister? Let me check. 1700 West Hillsdale Boulevard. It's pretty hard to turn a business trip into a pleasure trip, but you can make it more productive. With a portable computer, I can check my appointments, work on a script, ship it via modem, even agonize over the show's budget. How good are these portable computers? We'll find out next on The Computer Chronicles.
On the webpage of the HP Museum, I also found this audio recording. It's explicitly stated as being a 60 seconds clip from the Portable's original audio introduction tape of 1984.
I wonder how exactly this was done then. Was the salesperson showing you the still shots and promo material while the tape was on playback?
I don't know. Maybe, but let's just listen in briefly.
The Portable was designed to provide desktop capabilities in an 8.5-pound battery-powered use-anywhere package.
We basically started out with the ideal of a box being the size of a 3-inch notebook. That was our design goal. It had to be that size and it had to be totally battery-powered.
Hewlett-Packard, world leader in computer innovation, introduces the next step in personal computers, the Portable, the first fully functional personal computer in a truly portable package.
So it didn't include the entire playback, but if you're curious, I'll link it to the video description. The Portable 110 has a number of connectors on the backside, one being an RJ11 modem connector, another a serial RS-232 connector. I would be curious to investigate into serial transfers as well, as I heard that the pinout was actually not identical to the standard PC pinout. Additionally, there's the power supply plug and the two connectors for the HP interface loop, aka HPIL. The device itself was totally self-contained. Everything was stored in ROM. The MS-DOS 2.11 operating system as well as the bundled software suite, which include the then #1 productivity tool Lotus 123, ran from ROM, which means the system was instant on and you could start working with it immediately. At the time, additional ROM cartridges, so-called memory drawers, were offered in order to provide for additional software packages. When powering up this device the first time, or after a power loss, we get to see this message that it needs to be initialized. Simply pressing F1 will prepare the HP110 for use, which includes setting up an internal storage drive. It does so by dividing the aforementioned 272 kilobytes of RAM into two parts. One part, typically 96 kilobytes, is allocated to the real RAM, and the other part, 176 kilobytes, is allocated to a virtual drive A for data storage. Important to know is that this is non-persistent storage, so upon power loss, all data stored on the virtual drive A is essentially gone. Maybe you're familiar with later years ultramobile handhelds like the Pocket PCs running Windows CE, or intermediate products like the Atari Portfolio. These products had the same functionality to divide the built-in memory to RAM and a storage drive. The HP110 is the oldest machine so far that I could hold of myself to expose this particular feature. Speaking of the internal non-persisting storage, I need to check if the HP110 features a second standby battery to keep the RAM charged, so no data loss would occur when swapping out the main battery. When it comes to expandability, one question may be how to add persistent storage. This came in the form of the HP9114 external floppy drive, which cost a whopping $795 at the time of release in 1984. As you see, this is a bulky thing on its own, and you would probably think twice to carry it along with you back in the days. But it would give you a persistent storage option which was virtually unlimited, at least to the amount of floppy disks you would carry with you. There's some specialities about this floppy drive though. Let's start with the connectivity option, which is the aforementioned HP interface loop. As the name implies, it's a looped connection, so that means every device needs to be connected on both ends to the IL in and the IL out ports. Now with me having only the floppy drive to connect, this means there's two cable connections going forth and back between the floppy and the HP110. When this machine was released, the HBIL interface existed already for a few years, as it was established as a means to extend the popular programmable calculators with add-on devices. The HBIL was a serial connection that could connect up to 31 devices in a loop, and offered a bandwidth of theoretically 160 kilobits per second, though in reality was rather limited to 16 kilobits per second. The device options available range from floppy and tape drives to printers, video interfaces and many more, all of which featured the same standardized HBIL connector. All connected devices would get an ID automatically assigned, so the controller could properly address a specific device. This was indeed a great thing about expandability, and if anyone is now ringing a bell about plug and play, standardized plugs to connect many different peripherals over a serial connection, you may think,
aha, USB.
Well, HBIL is not USB, and HP was actually not part of the original design alliance, whom worked on the original USB specifications in the mid-90s. Still, in a broader sense, I think it's totally valid to see it like a conceptual precursor technology. Now about the second specialty of this drive. While it looks like a standard 3.5-inch floppy drive and it uses the same media, it totally is not. Whereas PC floppy drives rotate at 300 RPM, this one, according to some sources, seems to rotate at 600 RPM. Also, I read about the disk capacity, which oddly enough seems to be limited to around 630 kilobytes, quite a bit less than the usual 720 kilobytes of double-sided double-density floppy disks. This brings me the question if these disks are actually interchangeable between systems, which I believe is not the case. Anyways, to try this out, I have to configure it in the system configuration of the HP110, where we indicate we have one single floppy drive connected. And now with the system rebooting, let's see what happens.
He's dead, Jim.
Yeah, so it seems. I get only a quick sign of temporary life with the LEDs lighting up on the disk drive on power up, but then it's all dead. Let's do some measurement with the multimeter quickly. Okay, I see the battery voltage is down to 0 and I see no voltage on the backside connector. What happens if I disconnect the battery? Okay, now we get a reading. Let's quickly assemble it so I can try powering up the device. Alright, that looks a bit better already. Now I get some LEDs flashing and also the fault LED lights up. And then, after a few moments, everything goes dark again. But in my opinion, I should get to hear some activity on the floppy drive during power up, like a floppy drive seek or something. Also, when trying to access the drive on the HP110, there seems no whale. The HP110 uses drive A and B by default for the RAM drive and the built-in ROM, so the external floppy drive becomes C. Any subsequent drives would become D and E and so forth. Accessing this from DOS yields just an unrecoverable read error. Furtherly, I don't see any activity on the drive itself. I would expect to get some movement of the drive heads and the motor spinning up. It seems like I do have something to fix here after all. There's many online sources claiming that you can still operate this device with a dead battery. Well, at least in my own experience that's not true. Maybe these claims are true if the battery still has some leftover capacity, so not fully dead, but also not healthy enough to hold the charge. In my case, the battery was really dead, so there was only two options. Either build a new power circuit, bypassing the battery, or to get a new battery. As the original batteries are no longer made, I had to investigate a bit, and eventually found that the PowerSonic PS-628 is a well fit and still available today. Once the spare arrived, I had to only create some new connector plugs in order to hook up the new battery into the compartment. And then comes the moment of truth. Will it work? I go by configuring the external floppy drive again, as noted in the operations manual. And finally, I get some reaction on the next reboot, with the drive finally spinning up. Now, please don't ask me why the power LED is flickering, but it seems to be fine. At least, I seem to be able to format the floppy disk. You can also interact with the floppy drive via the text UI, but personally I like the CLI much better. After formatting, the capacity of the disk is reported with roughly 700,000 bytes. That's definitely less than the traditional double-density PC format. What's a bit odd though is the differing online sources, some claiming the capacity to be 630 kilobytes, others stating it as 690 kilobytes and sometimes even 710 kilobytes. If I take these roughly 700,000 bytes and divide it by another 1024, I end up at 684 kilobytes. So, if the format is not PC compatible, how to get software or data onto the HP110 then? Well, some historic software can be downloaded as disk images in a format created by the Teledisk utility. I tried recreating a floppy on this IBM PC convertible as it has a double density drive, but somehow that failed. Sort of successful working at first was to write out the disk image on this compact machine, although here as well I received a bunch of errors. As expected, even with the HP110 being able to read the disk index, the actual data on the floppy seems to be corrupted. Whatever I tried, I couldn't get anything to load up from the floppy drive. Either I received errors on corrupted data, or the machine simply froze when the corrupted binaries were loaded. I gave it many tries, even using yet another machine, this Bondwell M8, to create the floppies, but to no avail. Eventually, I had the HP110 perform a disk copy of one of these created floppies. Maybe that would work. I had not much hopes, as if it is corrupted, it stays corrupted. And while the disk copy was carried out without any errors, the result was, no surprise, still the same as before, with the machine locking up. So that doesn't work, but what other option is there? I learned that there was a tool called Form IBM that was previously published in the Portable Paper magazine, and it's claimed to allow the HP110 series to use the IBM format when formatting the disk. Hence, disks used in the HP110 could then be easily read back on the PC. But how to get the tool in the first place, as it was found in a historic Teledisk format file? There is a tool named TD-CVT, which can convert Teledisk images to an FDI image. And if that weren't obscure enough already, there's yet another tool, FDI to IMA, which can convert the FDI file into a raw disk image format, which then in turn can be read by WinImage or a similar imaging tool. Okay, eventually I got the files I wanted. As I totally failed to create a native disk suitable for the HP110, I gave it a shot. I took just the standard PC formatted double density disk, copied the files onto it and have the HP110 load up the disk. There's a bunch of ARC files, which is a specific compression format and needs the arc-E command to extract it. For reasons, my compact machine didn't want to run it. So it's kind of obscure having the HP110 load up the extracted files from a standard PC formatted disk. But it seems to work, at least until to that point that the procedure was aborted, as there was not enough room to extract the files directly onto the floppy disk. So I tried again, this time extracting the utility directly onto the RAM drive A. But that didn't work either. Is this data still corrupted? So I copied both the arc-E command and the arc file onto the RAM drive. And see here, this time round it worked. I was lucky. Both the COM and the doc files were extracted. It's just a question if it's working now. At least I can read the doc file, so that's a very good start. And what about the new formatting utility? It ends up a few moments later without a single error message. The check disk command reveals we now have a floppy disk with a total usable capacity of 728,000 bytes. This is a bit less than the actual PC format, but close enough. And my IBM PC convertible does not complain a single bit when reading that disk. Here as well, the check disk doesn't reveal anything bad except the slightly reduced disk capacity. So with that now being done, you may be wondering why I was complaining about the incompatible disk format in the first place, as it was all just fine reading the DOS formatted disk. Well, I cheated. Sort of. In the July 1989 issue of the Portable Paper magazine, I found this article which came with a disk compatibility chart. Maybe you paid attention that I originally started with the HP110, but then continued on the HP110 Plus. As soon as I found that the Portable Plus could actually read the IBM double density format by default, I came to the idea of extracting the files and copying them onto standard disks as shown before. Using this trick, converting the Teledisk image to FDA and this then to IMA, I could get hold of the files. And now, with the tool available on the Portable Plus, I can create discs from there, actually using the form IBM command that also the older HP110 can read and write to. And so now I have at least some ways for discs interchange. There's other options though. I found sources reporting about the disk driver written by Sidex, the HP110.sys and the P+.sys, which are good for reading the HP's original 9 sectors per track and 5 sectors per track disk formats on the PC.
So just installing the drivers to config.sys should be good, you say?
Apparently, but that's definitely a story for another time. And this concludes my first look into the HP Portable 110 series. There's a lot more to discover. I ended up investing so much time just around the floppy drive topic that I totally didn't find time to look at the custom RS-232 adapter for the serial line transfers, or how to make the modem working again. And yet, I would love to investigate into these obscure memory drawers that could provide additional software in ROM. These computers were quite progressive for the time. The HP-IL was definitely ahead of its time, and it integrated into an existing ecosystem of expansion units that were already around for the HP line of calculators. But why didn't they implement the floppy drive using the standard FAT12 format? My most likely assumption is the timeline. The HP110 came out in 1984 along with MS-DOS 2.11. MS-DOS and also IBM PC-DOS didn't officially support 3.5-inch double-density floppies until version 3.2, which only came in 1985. So even with the 3.5-inch floppy disks entering the market in 1981 already, initially even with a 360 kilobytes capacity, early deployments had to somewhat rely on a premature and pre-standard implementation. So in other words, the final FAT12 specification for the 712 kilobytes double-density floppy disks was not yet around by 1984. That's why. Again, it's my own assumption by simply looking at the timelines and known facts about when the double-density format was officially introduced to MS-DOS. Anyways, that's it for today. I'm the Vintage Collector and this was my story about the 110 Portable series. Thanks for watching and see you next time. If you check out this channel's community tab, you'll find some polls on potential upcoming videos. You're very welcome to upvote on upcoming topics or drop in new ones you'd like me to chase down.